Hi class, it's Mrs. Kane here with your next e-learning video. I'm going to continue talking about trig functions today, and specifically we're going to talk about some applications of trigonometry. Before we get into the applications, we're going to do a quick warm-up. You can either pause the video and try the warm-up on your own, or if you want a refresher with me, I'm going to go ahead and explain how to find the 6 trig functions. So for a warm-up, it says, given the triangle below, find the length of the missing side and then evaluate each trig function and find the measure of angle A. So we have a right triangle and we know 2 out of 3 sides. So I'm going to start by using Pythagorean theorem to find the missing side. So I'm going to call this side x, and I know that 9 squared plus x squared equals 15 squared. And so 81 plus x squared equals 225. And then we're going to subtract 81 from both sides. 225 minus 81 is 144. And then we're going to take the square root of 144. And the square root of 144 is 12. So I'm going to erase x, and I'm going to go ahead and label this missing side here 12. Okay? So the first set of questions asked me to find the 6 trig functions with regards to angle A. So I'm going to find angle A, and this is going to be my first reference angle. And so I'm going to start by labeling my side. So I know that the 15 is the longest side. It's also opposite my right angle. And so that side is my hypotenuse. Okay, and then if I use angle A, the 12 is the opposite side. And then the 9 is the adjacent side. And I'm going to go ahead and write SOHCAHTOA on the top of my paper to remind me of the trig ratios. So to find the sine of angle A, it's the opposite side over the hypotenuse. And so I have to do 12 over 15. Now notice that I can reduce that fraction. They are both divisible by 3. So I'm going to go ahead and reduce that to 4/5. Okay, my cosecant is the reciprocal of the sine, and so that's going to equal 5/4. So when you reduce, you want to go ahead and flip the reduced form when you are trying to find the reciprocal functions. The cosine of angle A is 9 over 15. Again, those are both divisible by 3, and so I'm going to reduce that to 3/5. And then the secant is going to be the reciprocal of the cosine, which is 5/3. The tangent of angle A is the opposite side over the adjacent side, so I get 12 over 9. And then if I divide by 3, I get 4/3. The cotangent is the reciprocal of that, which is 3/4. The last set of questions ask about the tangent of B and the cotangent of B. And so I'm going to erase my adjacent and my opposite labels. And I'm going to move to angle B, and now the 9 is the opposite side, and the 12 is the adjacent side. And so the tangent of angle B is going to be 9 over 12, which reduces to 3/4, and then the cotangent is going to be 4/3. Okay, now the last question says to find the measure of angle A. So I'm going to go back to angle A. Okay, and I'm going to relabel the 12 as the opposite side and the 9 as the adjacent side. And I'm going to pick any 2 sides. I'm going to use the 12 and the 15. Okay, so the 12 is opposite, the 15 is the hypotenuse. And so I know that the sine of angle A equals 12 over 15. Okay, and then just a reminder, let me change that color so it kind of stands out a little bit. A reminder from the previous lesson, when you're trying to find a missing angle, if you know that the sine of angle A is 12 over 15, to find the measure of angle A, you're going to do the second button in your calculator. You're going to do second sine of 12 over 15. So when we find missing angles, we use that inverse button. So second sine of 12 over 15, okay, and we get 53.1 degrees. Okay, and you could have used, you did not have to use the sine. Okay, you could have said that the cosine of angle A is 9 over 15, and you would have gotten the same answer. Notice if I did second cosine, and I use 9 over 15, Okay, you get the same answer. Okay, so today we're going to practice some applications of trig. So we're going to solve some right triangles. We're going to find some missing parts of a right triangle. But before we do that, we're going to have to use some context to draw some pictures. So the first problem says a water skiing ramp rises at an angle of 15.1 degrees and is 19 feet long. What is the height above the water that the skier leaves the ramp? All right, so we've got some water and we have a ramp in the water. All right, now the key is when you're drawing these pictures, you're trying to create right triangles, okay? And so for this particular problem, it says that the skiing ramp rises at an angle of 15.1 degrees. So I'm going to label this angle 15.1 degrees. And it also says that the ramp is 19 feet long. So the ramp is 19 feet. Okay, and the question is, what is the height above the water that the skier leaves the ramp? So we're assuming that the skier is going to leave the ramp right here. And so the height above the water is going to be this distance right here. Okay, so from the previous lesson, remember we always start with the reference angle. Okay, so we're working with the opposite side and the hypotenuse. So opposite and hypotenuse is the sine. So we know that the sine of 15.1 degrees equals x over 19. Okay, and you can turn that into a proportion by putting a 1 underneath the sine. And then if you cross multiply, x times 1 is x, and that equals 19 times the sine of 15.1. And so as long as your calculator is in degree mode, you can go ahead and type that in, 19 times the sine of 15.1. And our answer is 4.9 feet. Okay, so just kind of an extension of the problems that we talked about in the previous video. All right, so if that made sense, go ahead and pause the video and try the next problem. If you want a little more practice, we'll do another one. It says a support cable stretches from the ground to the top of a 208-foot radio tower. All right, so we've got a radio tower. I'm going to make kind of a simple tower here. Okay, and it says that this tower is 208 feet. All right, so I have a 208-foot tower. And I have a cable that is on the ground stretching to the top of the tower. So here's my right triangle right here. Probably could make that straighter. We have a right triangle right here. If the cable measures 250 feet, so the cable is 250 feet, what angle does it make with the ground? So what angle does the cable make with the ground? And so we're trying to find this angle right here. Okay, and so again, if we start with that reference angle that we're looking for, we're working with the opposite side and the hypotenuse. And so this time the sine of the angle equals 208 divided by 250. And again, when we're trying to find a missing angle, we do the second button on the calculator. We're going to do inverse sine of 208 divided by 250. So second sine of 208 divided by 250. And you should get 56.3 degrees. So when you're looking for an angle, you're going to label it with degrees. Okay. All right, the last thing I'm going to talk about today is something called angles of elevation and depression. And these are angles of sight. And to introduce or to remind you of what an angle of elevation and depression are, I want you to think about two people that are standing. One, I have Steve is on the sky deck of the Willis Tower, and Kristen is on the observation deck of the John Hancock Center. So if you look at this picture, you've got Steve is standing on a building above another building where Kristen is standing. And they are looking at each other, okay? And so if you have a line of sight from a person up to an object or another person, then we call that an angle of elevation, okay? So I am standing on this tower and I am looking up at Steve. And so the angle formed by my line of sight up and a horizontal line along the ground is called the angle of elevation. Okay, now because Steve is looking down at me, his angle is formed by a horizontal line parallel to the ground and a line of sight down towards me. Okay, and so notice that the angle of depression and the angle of elevation are congruent. They have the same measure. Okay, and a quick review from geometry. Why are these angles congruent? Okay, they are called alternate interior angles. Okay, and this is not something I'm going to be quizzing you on, but you're going to notice in our second problem that when you're trying to find an angle of depression, we actually use the angle of elevation to find that missing angle. Okay, so just kind of an illustration of what we're looking for if we're asked to find an angle of elevation or an angle of depression. So we're going to continue with our word problems, but this time we might have to find an angle of elevation or depression. So the first problem, or the next problem, says from a point on the ground 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. So how tall is the flagpole? All right, so we've got a flagpole. I'm going to make a simple little flag coming off of that. All right, and it says from a point on the ground 12 feet from the base of the pole. So here's the base of the flagpole, and we're looking at a point on the ground 12 feet from the base of the pole. Let me make that a little smaller. So 12 feet from the base of the pole. The angle of elevation of the top of the pole. So from 12 feet away to the top of the pole, this angle is 53 degrees. So remember, an angle of elevation is formed by a horizontal line and a line of sight going up. So the question is, how tall is the flagpole? It doesn't really look like a flag. I feel like I need to fix that. Let's just go like this. All right, so the question is, how tall is the flagpole? Okay, so again, as long as you know how to draw the picture, now we have our angle, and we're working with the opposite side and the adjacent side, and so we know that the tangent of 53 degrees equals the opposite side over the adjacent side, and then we can go ahead and cross multiply. X equals 12 times the tangent of 53 degrees. And in the calculator, we do 12 times the tangent of 53, and we get 15.9, and so the flagpole is 15.9 feet tall. All right. Now the last problem says a pilot is flying at an altitude of 4.6 miles. So altitude means height. So I'm going to go ahead and draw an airplane. And I'm going to label this airplane 4.6 miles above the ground. All right, along the ground, his plane is still 16 miles from the airport. So, whoops. So the airport, let's assume the airport is 16 miles away, 16 ground miles away. So this is the airport, and so he's still 16 miles away from the airport. Okay, what is the angle of depression from the plane to the airport? Okay, so I'm going to draw a line of sight from the plane to the airport. And here's the tricky part. A lot of students like to say that this here is the angle of depression. Okay, but remember that an angle of depression has to be formed by a line of sight, which is this line here, and a horizontal line. And so you actually need to draw in the horizontal line. So this is your angle of depression. So this is the angle that we are looking for. So if I put an X here, okay, notice that's not part of my right triangle, but we know that the angle of depression is the same as the angle of elevation. And so I'm actually going to call this angle down here X, and then I can use trig to find my missing angle. So if I think about this angle of elevation, which is equal to my angle of depression, okay, I'm working with the opposite side and the adjacent side, and so I know that the tangent of X equals 4.6 over 16. And so to find that angle, I'm going to do inverse tan of 4.6 over 16. Okay, so second tan of 4.6 over 16. And so that angle measure is 16.0 degrees. Okay, so that angle of depression can be a little tricky. Just remember that it's equal to your angle of elevation. All right, thanks.